All right, so today's lesson is all about functions. A function is a fancy word for a relationship between two things. And you've actually dealt with functions before in the form of in-out tables. In-out table is where we have an input, we do something to it, and we get an output. So let's just start off with a real-world example. Let's try to look at the relationship between the number of quarters that you have and the corresponding number of cents that you have. So if we're looking at this as an in-out table, the number of quarters would be our input. We do something to that to get the number of cents. That would be our output. Instead of calling them in and out, we're now going to refer to them as variables. So our input is our X value. Our output is our Y value. That's going to be important here in just a minute because we're actually going to write a rule for this function. All right, so let's say I have some number of quarters. So let's say we have 0, 1 quarter, 2 quarters, 3 quarters, 10 quarters. All right, so if I had 0 quarters, I would have 0 cents. If I had 1 quarter, I would have 25 cents. 2 quarters, I would have 50 cents. 3 quarters, I would have 75 cents. We're going to save this 10 here for just a second. So what we can now do is look at what are we doing to our X value, our input, to get our Y value, our output. So sometimes your function, your rule might be adding a certain number. So from 0 to 0, we'd add 0. From 1 to 25, we're not adding 0. From 2 to 50, we're not adding 0. So with a function, your rule has to be constant, right? We're not suddenly going to change our rule because this relationship between quarters and number of cents is constant. It's not changing. So for this example, our rule cannot be plus something. So if it's not plus something, it often helps to look at, okay, maybe it's multiply by something. So in this case, 0 times, right, anything is going to give you 0, so that's not really a helpful point. But 1 times 25 would give us 25. 2 times 25 would get us 50. 3 times 25 would get us 75. So it looks like our rule is times 25. So finding the rule of our function, our rule would be times 25. We then can use that rule to solve for a missing number. So how many cents would 10 quarters be? So we take 10, our input, multiply it by our rule we just found, which is times 25. So 10 quarters would give us 250 cents. So we can use that rule to find and solve for a missing piece. Now, when writing a function, we always write it as y equals something done to x. So we're getting our output by doing something to our input. And in this case, our rule was times 25. So we're taking x and we're multiplying it by 25. So our function, our rule, would be y equals 25 times x. And we can plug in our different values just to prove that's true. If x is 1, 25 times 1 is our output y, which is 25. 25 times 2 is 50. 25 times 3 is 75, and so on. So we have created a rule for our function. This would work for any number of quarters. Again, this relationship is constant. If I had 1 billion quarters, I'd take 25 times 1 billion to find the number of cents that I've got. All right, let's look at another one. So I am going to give you an in-out table, a function table with some known values and see if we can find our rule. So let's say x is 0, y is 3. X is 1, y is 4. X is 2, y is 5. X is 13. What is y? So again, our rule can be multiplying, it can be adding, it can be subtracting, it can be a combination of the two. So I always like to check for multiplication first. And we're going to quickly see that this isn't going to work as multiplication because 0 times nothing gives you 3. There's no way to get from 0 to 3. Let's say that one wasn't there. Okay, to get from 1 to 4, it would be times 4. So if our rule was times 4, 2 times 4 would give us 8. So we can see that that doesn't work. So our rule is not times 4. If you're struggling finding a rule that involves multiplication, chances are your rule isn't multiplication. And in this case, it's actually addition. And our rule in this case is going to be add 3. So how are we getting our y value? We're taking x and we're adding 3. So 0 plus 3 is 3, 1 plus 3 is 4, 2 plus 3 is 5, 13 plus 3 would give us our mystery number here of 16. And our function, our rule, for this case is y equals x plus 3. Then, another task it might ask you to do is to graph it. Well, we've got ordered pairs, right? We've got 0, 3, 1, 4, 2, 5, and so on. Using this rule, we actually could come up with an infinite number of ordered pairs. So if you're going to graph it, right, get yourself a coordinate grid. Hopefully you've got graph paper so it doesn't look as sloppy as mine. Just put a few points on there just to show you real quick. Remember, y is always our vertical axis. X is always our horizontal. So then we could plot these. So we've got 0, 3 as our first point. That would be right there on the y-axis. 1, 4 would be our next point. 2, 5 would be our next point. And because this relationship is constant, when we graph it, we put a line through it, we actually should have a straight line, right? And it does actually go on into the negatives in this example. Not all functions make sense to have negative numbers. Like our last example, you can't have negative quarters. But this example, you could. And these arrows show that it goes on forever in both directions. So at some point, way like up over here, on this line, I would have that point 13, 16. So you can use your rule, find your x and y values. Remember, x is your input, y is your output. Your rule is what do we do to the input x to get the output y. And then last step, if asked, you can graph it on a coordinate grid.